Gating ratio. The gating ratio refers to the relation between the area of the choke to total area of runner, total area of gates. Mathematically, it can be written as AC, AR, AG. AC is for choke, AR is for runner, AG is for in-gates. The gating system completely controls the molten metal flow. Gating systems can be classified as pressurized system and unpressurized system. Gating ratio depends on the nature of the molten metal. The pressurized system is used for reactive metals like magnesium alloys, etc. The unpressurized gating system is used for normal metals such as brass, steel, aluminum alloy, etc. A gating ratio such as 1:2:1 or 1:0.75:05 refers to pressurized system, whereas the gating ratio such as 1:2:2 or 1:3:3 or 1:1:3 refers to the unpressurized. Pressurized system is referred to as gate control system, since in-gates controls the flow of metal. Unpressurized system is referred to as choke control system, since the choke controls the flow of metal. In the pressurized system, high metal velocity occurs and results in turbulence. In the case of unpressurized system, turbulence is produced and streamline flow is induced. Pressurized system consumes less metal and yield is more. Unpressurized system consumes more metal and the yield will be slightly lower. In the case of pressurized system, the system will always be full of liquid metal. In the case of unpressurized system, flow is not. Now we have some guidelines for designing gating system. The size of the sprue fixes the flow rate. The amount of molten metal that can be fed into the mold cavity in a given time period is limited by the size of the sprue. The sprue should be located at certain distance from the gates so as to minimize velocity of the molten metal at end gates. Sprue should be tapered by approximately 5% minimum to avoid aspiration of the air and the free fall of the metal. End gates should be located in thick regions. Locate the gate so as to minimize the erosion of the sand mold by the metal stream. This may be achieved by orienting the gates in the direction of the natural flow paths. Multiple gating is frequently desirable. This has the advantage of lower pouring temperatures. These will improve the metallurgical structure of the casting. In addition, multiple gating has to reduce temperature gradients in the casting. Now this is the conclusion. To reduce warpage, proper gating system plays a major role in the castings. Optimized gating system improving casting quality and increasing casting yield. Optimum gating position leads to sound castings. Proper gating framework are essential to secure quality of castings. Now, this is the end of this chapter. Students, I think you might have understood well about this topic. Still, if you have any doubts, you can ask me questions. Or, you have another option for you. If anybody wants my direct tutoring on the web, you can contact me. I can teach you on Skype or Zoom platforms. Thank you very much.